Today we're going to be talking about subject recruitment, or what's also called sampling. Some things we'll think about are who should be included in the study, and that depends upon the population of people you're interested in. So you might think about this before we begin. And who do we include in a study? And that often influences the research findings. And we can have bias when we do that, called sampling bias, and I'll tell you about that a little bit later. Let's start by talking about, imagine you're a presidential pollster. Who would you include? Let me show you a picture here. This is a famous picture, and it says Dewey defeats Truman on it in the Chicago Daily Tribune. And that's a picture of Truman holding it the day after he won the election to be president of the United States. So this newspaper incorrectly predicted that Mr. Dewey, Mr. Thomas Dewey, was going to win the election over Truman. So it's kind of a funny example of how pollsters can get it wrong. I guess what happened is there was one political analyst who had been right 4 out of the 5 last times that there was an election, and he predicted that Dewey was going to win, and most of the pollsters predicted that Dewey was going to win. But in the last 2 weeks, a lot of voters changed and voted for Truman. So people were pretty happy, or Truman was pretty happy and his followers about that. But the point about what we're talking about now is a mistake was made in the polling and in the analysis. And a lot of mistakes have been made in previous presidential polling, and we'll talk about those in a little bit. How would we try to figure out who we think is going to win an election? Well, we need to survey perhaps a lot of U.S. voters. Now, surveys are usually designed to study a specific population. We might say our population of interest is all U.S. voters. So that's a collection of individual people sharing specific characteristics, so U.S. voters. What population of people do election polls attempt to survey? Well, voters are usually, they have to be over a certain age, they have to be citizens, they have to register to vote. Okay. Now, what if we wanted to really try and get every single voter in the U.S.? Well, that's called the same thing as what's a study of every person in the U.S. Do you know what it's called when you study every person in the U.S.? And I'll give you a hint. It happens every 10 years. It's a census. That's C-E-N-S-U-S. There's a major disadvantage, though, if you ever want to try and collect data from everyone in your population. That's a ton of people usually. It's very time-consuming and expensive to get results from every person in a population. Okay, so what's the solution to this? And this is what we do in research. We collect a sample. Sample is a group of people in the population who are believed to be representative of that population. In other words, it's a subgroup of people from the population. That's an easier way to think of it. You might write that down. A good sampling plan should result in a sample that accurately represents the population. So if we want an accurate representation of all U.S. voters, we should find out what percentage are all women of all voters, what are men, what percentage are Democrats rather than Republicans, what percentage are higher income and other types of income, what percent are from different regions, and think about any other variables you think would affect what someone would vote, how someone would vote in an election. I actually like this next visual. I'll show you here. It shows how you have a population of interest, and from that you draw a sample. Notice here how there's about the same number of people of different colors as here and different heights. This can be one variable of interest to you, like let's say you want to make sure you get everyone with a certain hair color, light hair, dark hair, or maybe you want to make sure you have people of different ages. But I like this how it reminds people the population is a large group of people that you're interested in, and you take a sample. So if this were U.S. voters, which it can't be if you're looking at the little kids, but we want to just make sure that you have a nice variety. Now the sample should have very similar characteristics to the population of interest. Now let's say you want to look at, make sure you have similar ethnicity. If there's 30% of people who are, say, Latino in your population, you want your sample to have the same amount. Sometimes if you have a very large sample, that can help ensure that the characteristics of your sample are similar to the population, but it doesn't always work that way. if you want to be a little more careful, you can do a random sample. Let me tell you what a random sample is. A random sample means that each person in a population, such as all U.S. voters, has an equal chance of being selected for the study. So if you want to predict all U.S. how people are going to vote, you get a smaller sample. But you make sure you have some method that everyone in the population has an equal chance of being selected. So there's a variety of ways you might have heard in other research methods topics to do randomization. For example, there's something called random digit dialing, use of random numbers, etc. I used to have a job in market research where I would be given a set of random numbers. I don't think I even dialed. I think the computer dialed random numbers, and every number in their list of numbers had an equal chance of being called. And so I would just be on the other side, waiting for a real person to answer. And I got a lot of fax machines and wrong number, I guess, like businesses that I wasn't supposed to talk to, just more people. Just our goal was to help people try out a new car and get them to come in and see if they wanted to try out a new car and tell us about the car. But I remember learning a little bit about random sampling in that case. I'll talk about some of these other methods in a moment, but a more formal definition of random sampling is the process of choosing a sample by chance procedures with known probabilities or mathematical chance of selection. If that's a little advanced for you, don't worry about that if English is not your native language. Some scholars call random sampling by another name probability sampling because probability plays a role in this. Now, the use of random or chance procedure is an attempt to obtain a representative sample. Now, when you're doing random digits, you might think about creating a list of random digits that you can get online. A computer can create it, and you can use tables of random digits to get a random selection. So let's say for some reason you only had 4 people in your population of interest, and let's say it's Mike, Pete, and then there's 2 more. Let's say there's Julie and Doris in your sample. In your population, and you have to get it down to 2. You can look online, you can type in the numbers 1, 2, 3, 4, and you can assign each person one of those numbers. And the computer will spit back the numbers randomly, like it might say 3, 4, 1, 2, for example. And that means that the 3rd person and the 4th person, which would be, let's say, Julie and Doris, get to be in the sample, but the first 2 don't. Okay? You can look up more on this online if you want to know more about this. A common problem is sampling error. A sampling plan can have errors, biases, and limitations. I'm going to pause there. You might take a moment to pause and think about what you learned so far. So what does sampling error or sampling bias look like? Well, let's take an example first. There's an example. In presidential elections, we have some examples. I mentioned the 1948 pollsters who predicted that Dewey would win the presidential election over Truman, and that was incorrect, and I mentioned why. We have some even more interesting results from the 1936 presidential election of Roosevelt versus Landon. And apparently the Literary Digest polled 2.4 million voters, or people at least, and even with that many people, they got the wrong results. So what happened? Well, they sampled a certain type of person. They sampled more wealthy men who drove cars, who had a phone, who were Republican, than other types of people. They got their list of potential voters from car registries, I think. They got them from phone registries and places where it was actually just people who had money would have their name and address or even phone number listed. So even with all those people, they actually got the wrong result because they sampled the wrong people. They sampled a certain set of people or a certain type of people. I hope no one got fired from their job for that, but I would imagine that was a major, major mistake to make. They definitely needed to have a more representative sample of the population of U.S. voters who were voting that year. sorry. When we talk about polling, how good are pollsters and people who do polling these days, and how good are they just in general? We can talk a little bit about in the past. Gallup, who was famous for starting the Gallup organization, Mr. Gallup he does a lot. His organization does election forecasting, and they've gotten quite good after he studied many of the mistakes in the past. As of 1956, their organization had a 1.7 margin of error. So they were correct up to 1.7% above or below their prediction. So what does that mean? Okay, so let's say we're looking at the election of Bush versus Kerry in the US presidency. And let's say the state of Nevada, before the election, has 51% who say they're going to vote for Bush and 47% who say they're going to vote for Kerry. And Gallup finds that to be true as what he forecasts. Imagine that were the case. If that's true, we can be fairly confident, or Gallup would have been confident, within that 2% margin of error, that that is probably what's going to happen, that the state of Nevada is probably going to vote or elect Bush. Now in Colorado, if 46% of the voters vote for Bush and 45% for Kerry, that is too close to call. A prediction of that nature would probably be incorrect. Or at least we don't know for sure. We just couldn't be confident in it, I should say. Today, we expect a 2 to 3% margin of error. Another point I'd like to make is that convenience samples are really what most of us use. We really don't need to worry about margin of error or probabilities if we're using a convenience sample, which means a sample of easy to access subjects. They're usually nearby, they're available. Student volunteers is a great example of that. I would imagine many of you listening have done student team research, and perhaps you just used a class or two to take your survey, or maybe you handed out your survey to friends. There's nothing random about that. There's no probability that you used. You just took a sample of your friends, and we call that a convenience sample, as I mentioned.